Hello everyone, welcome to Siddharth's class. Now in today's class we'll learn about real numbers. Before we start with real numbers, let me give you a brief idea about the number system. Now all of us are aware of different types of numbers, is not it? Now let us learn what are those different types of numbers. Now if I classify the real numbers, then I will have rational and irrational. So real numbers are divided into two parts, real rational numbers and irrational numbers. Now what are rational numbers? I'll just give you an example. Any number which is in the form of p by q, where q is not equal to 0 and p and q are integers, where p and q are integers. Now what are irrational number? Any number which will not give you a rational answer, that is a irrational number. I can give you one example in terms of terminating and non-terminating. Rational numbers are those numbers which are terminating decimals, and irrational numbers are those numbers which are non-terminating decimals. I will give you an example: root 3, root 5, root 7, and so on. So these are some types of irrational numbers. Now let us come to rational numbers. A rational number again can be classified into two parts, that is integers and fractions. Rational number can be classified into two parts, integers and fractions. What are integers? Again, integer means the collection of negative numbers, positive numbers along with 0. I write on -3, -2, -1, 0, 1, 2, 3 and so on. What are fractions? Fractions means anything which is in the form of p by q. Example, 1 by 2, -4 by 9 and so on. Now, integers are again classified into whole number. Now, what are whole number? All the positive number along with 0. And lastly, we have natural number. What are natural numbers? All the positive numbers, all the counting numbers are called natural numbers. This is a basic idea of a number system. Now, again, real number classified into two parts, rational and irrational. Rational is further classified into two parts, integers and fractions. And integer is further classified in two parts, whole numbers and natural numbers. So this gives us the basic idea of a number system. Now we can start with the exercises. Let us start with exercise 1A. In question number 1 it says, use Euclid's division algorithm to find the HCF of each of the following pairs of numbers. Now first question gives you 18 and 24. Now you have to find out the HCF of 18 and 24, not by traditional method, but using the method of Euclid's division algorithm. Now let us start. The given numbers are 18 and 24. By using Euclid's division algorithm, we have. Now, between these two numbers, which is bigger? 24. So, write down 24. Now, what can we do? You divide 24 by 18. Let us divide 24 by 18. 24 divided by 18. 18 ones are 18. How much remainder? 6. Now, this 24 can be written using Euclid's division algorithm as 18 into 1 plus 6. Now, how can I write this one? If you recall, there is a formula which says dividend equals to divisor into quotient plus remainder. So this is our Euclid's division algorithm. So using this method, we will find out the HCF of 18 and 24. So among between these two, which is bigger, 24? So divide 24 by 18 and write down in this form. Divisor into quotient plus remainder. Now what is dividend, what is divisor, what is quotient, what is remainder? The number which is being divided, that is called dividend. The number which you use to divide, this is called divisor. This is called quotient and this is called remainder. Now again, 18, write down 18 here. Divide 18 by 6. Let's divide 18 by 6. 6 3s are 18. Remainder is 0. So I write down 6 into 3 plus 0. Now since the remainder is 0, we cannot divide further. And we already got the answer now. This is also a remainder. This is also a remainder. So what is the HCF? So the HCF is the last non-zero remainder. This is a zero remainder. This is a non-zero remainder. Therefore the HCF is 6. Therefore HCF of 18 and 24 equals to 6. That is our answer. This method is very simple, but you must not be confused in this one. Dividend equals to divisor into quotient plus remainder. This is division algorithm. In this question number 2, we have 70 and 30. So the given numbers are 70 and 30. By using Euclid's division algorithm, we have again, which is bigger between these two? Write down 70. Now you have to divide 70 by 30. How will you divide? Divide 70 by 30. 30 2s are 60. Remainder is 10. This is a dividend, divisor, quotient, remainder. So write down 70 in the form of 30 into 2 plus 10. You have still a remainder which is not 0. Further divide 30. Now divide 30 by 10. 10 3s are 30. Remainder is 0. Divisor, dividend, quotient, remainder. So this 30 can be written as 10 into 3 plus 0 again. We got 0 here. Stop. We cannot divide further. So this is a 0 remainder. This is a non-zero remainder. Which is our answer? This is our answer. Therefore, HCF of 70 and 30 is 10. That is our required answer. Let us go for next question. Let us try this question number 3. The given numbers are 714 and 924. By using Euclid's division algorithm, we have, which is bigger? As per the rule, divide this one by 714. Let us divide. 714 divides 924. Let us divide. 714 1s are 714. 4 minus 4 0. 2 minus 1 1. 9 minus 7 is 2. So you have to write down this in the form of 714 into 1 plus 210. Still the remainder is not 0. So divide this by this. Again, you have 210 divides 714. 210 3s are, let us try. 4 minus 0, 4. Carry 1. 11 minus 3, 8. 6 minus 6, 5. That's 84. So write down 714 into the form of 210 into 3 plus 84. Again, the remainder is not 0. Divide this 210 by 84. Let us divide again. 84 will divide 210. 84 twos are 4 twos are 8, 8 twos are 16, 168. Now, carry here, 10 minus 8 is 2. This is 20. 20 minus 16 is 4. So you have 42. So 210 can be written as 84 into 2 plus 42. Still the remainder is not 0. Let us go one more time. Divide 84 by 42. 42 will divide 84. 42 twos are 84, and yes, the remainder now becomes 0. So let us write down 42 into 2 plus 0. Now it becomes easy now. Now we got the remainder as 0. So the HCF will be the last non-zero remainder. Which is the last non-zero remainder? This is also a remainder, this is also a remainder, this is also a remainder. So which is the last non-zero remainder? This is the last non-zero remainder. 42 is the last non-zero remainder. Therefore, HCF of 714, 924 equals to 42, which is our required answer. Let's go for next question. Let us try question number 2. In question number 2, the question says, using Euclid's division algorithm, find the HCF of each of the following pair of numbers. The first, number 1 says, there are 3 numbers now. In question number 1, there were 2 numbers. Now here, there are 3 numbers. You have 296, 999 and 925. Now what to do now when there are 3 numbers? It's very simple. Take any 2 numbers, but I prefer taking the 2 biggest numbers. First I'll taking 999 and 925. Using Euclid's division algorithm, we have now between these 2 numbers, which is bigger? 999. So divide 999 by 925. Let us divide here. 925 will divide 999. 925 ones are 925. You subtract. 9 minus 5, 4. 9 minus 2, 7. So 999 can be written as 925 into 1 plus 74. Now you divide 925 by 74. So 925 divided by 74. 74 will divide 925. Let us divide. 74 ones are 74. Carry here 1. 12 minus 4 is 8. 8 minus 7 is 1. This 5 will come down. 185. 74 twos are 148. Now you subtract again. Carry here 1. 15. 15 minus 8 is 7. This is 7. 7 minus 4 is 3. Now 925 can be written as 74 into 12 plus 37. Again the remainder is not 0. Go further. Divide 74 by 37. Let us divide. 37 will divide 74. 37 twos are 74. Remainder is 0 now. So you can write down 37 into 2 plus 0. Now the remainder is 0. Let us stop here for these 2 numbers. So if you consider these 2 numbers, the HCF is 37 now. So the HCF is 37 now. So you can write down, therefore HCF of 999 and 925 is 37. The answer is not yet complete. Let us try again, another part. Now, out of So given three numbers, two numbers has been taken. Now what is left? This is left. Again, taking down here, again taking 296 and 37. Why 37? Now 37 is the HCF. And why have we taken HCF? Because we are finding the HCF. Now again, using Euclid's division algorithm, we have, which is bigger? 296 is bigger. Divide 296 by 37. Let us divide. 37 will divide 296. 37, how much are 296? 37, 8s are, 8 7s are 50, 6 carry 5, 8 3s are 24, 24 plus 5, 29. So remainder is 0 directly. So 26 can be written as 37 into 8 plus 0. Now here you got the answer 0 directly. So what is the answer? You got the remainder 0. In the first step only you got the remainder 0. So what is the answer? So the answer is 37. Why? Here you don't get any remainder. The remainder is 0 here. So go up. 0. Here also 0. Again go up. 37. So 37 is the answer. Okay? Hence, HCF of all the three numbers, 296, 999 and 925 is 37, which is our required answer. So if there are three numbers, use the same method that we have used in question number 1. Take any two bigger number. Actually you can take any number, but I prefer taking bigger number. Let us make a rule. So I follow the rule of taking two big number, that's completely fine. So in this way, we can find the HCF of given three numbers. Let us do one more of the same type. Let us try question number 3. Here we have three numbers, 1215, 513, 1134. So taking 1134 and 1215. Now using Euclid's division algorithm we have, which is big? Which is bigger? 1215 is bigger. So divide 1215 by 1134. Let us divide. Let us divide here. 1134 will divide 1215. 1134 ones are 1134. Now when you subtract, we have 81. So this can be written as 1134 into 1 plus 81. Now again, the remainder is not 0. Let us divide this. 1134 by 81. Let us divide. 81 will divide 1134. 81 ones are, let us do in this way. 81 subtract 3 minus 1 2, 11 minus 8 3, and this 4 will come down. 81 3s are 81 4s are 4 ones are 4, 8 4s are 32. So now the remainder becomes 0. You can write down 81 into 14 plus 0. Now in this case, you got the remainder 0. Therefore, the HCF is 81. Therefore, HCF of these two numbers, 1215 and 1134 is 81. Now, again, taking. Now, which number is left now? This is left. 513 is left. Let us take 513 and 81. 513 and 81. Now, let us divide as per the rule. 513 is bigger, so let us divide 513 by 81. Let us divide here. 81 will divide 513. 81, let us do how much? How much are? 81, 5s are, 81, 6s are. 6 1s are 6, 6 8s are 48. Let us try. 13 minus 6 is 7. 50 minus 48 is 2. You have 27. So you can write down 81 into 6 plus 27. Still the remainder is not 0. Let us divide 81 by 27. Divide 81 by 27. 27 3s are 81. So the remainder becomes 0. 27 into 3 plus 0. In this case, now we are getting the remainder 0. Not directly, we did not get here directly as we got in the last question. So here we got 27 and then 0. Therefore, the remainder is 27. So you can write down, hence, HCF of all the three numbers 1, 2, 1, 5, 5, 1, 3 and 1, 1, 3, 4 equals to 27. That is our required answer. So if you have two numbers or if you have three numbers, the method is same. Of course, when you have three numbers, the method is doubled. You have to do 2 times, and when you have two numbers, it's simple, it's easy to solve. Let's move on to the next question. Let us now try question number 3, which says, find the largest positive integer which divides 615 and 963, leaving the remainder 6 in each case. Means, when you divide this one by the required number, the remainder is 6. When you divide 963 by the required number, the remainder is 6. So you can write down, when we divide 615 and 963 by the required number, the remainder is 6. So what do we do? Since the remainder is 6 and here the largest positive number means HCF, and when you find the HCF, the remainder must be 0, is not it? So what do we do in order to make the remainder 0? We subtract this 6 as a remainder, which is a remainder from these two numbers. 615 minus 6 equals to 609 and 963 minus 6, which is equals to 957. Again, since the remainder is 6 and we have to find the HCF, in HCF the remainder cannot be 6, it has to be 0. So we subtract 6 from both the given numbers. Therefore, what is our required number? Our required number is equals to HCF of 609 and 957. By using Euclid's division algorithm, we get, now as per the rule, which is bigger? 957 is bigger. So you write down 957, you divide 957 by 609. Let us do here. 609 will divide 957. 609 ones are 609. Let us try. Subtract. 17 minus 6 will give you, 17 minus 9 will give you 8. This becomes 4. 4 minus 0 is 4. 9 minus 6 is 3. So you write down 609 into 1 plus 348. The remainder is still not 0. Now divide 609 by 348. Let us divide 609 by 348. 348 ones are 348. 9 minus 8 1. 10 minus 4 6. 5 minus 3 2. 261. You will get 348 into 1 plus 261. Again divide. The remainder is not 0. Divide 348 by 261. Let us divide. 348 will be divided by 261 again. Ones are 261. 8 minus 1 is 7. 34 carry. 14 minus 6 is 8. You have 261 into 1 plus 87. Again the remainder is not 0. Let us go one more step. 261. Divide 261. Let us divide 261 by 87. 87. Let us try. 3s are 7 3s are 21. Carry 2. 3 8s are 24 plus 2 26. Now the remainder is 0 if you look at here. Now you can write down 87 into 3 plus 0. Since the remainder is 0, so therefore the HCF is the last non-zero remainder. This is our answer. And as per the law, as per the rule, I mean, what is asked in the question? The question says, find the number, and our number is HCF. Hence the result, hence the answer of this question becomes 87. You can write down. Hence, the required largest positive integer is 87, and that is our answer. Let us move on to next question. When you divide 445 by the required number, the remainder is 4. When you divide 572 by the required number, the remainder is 5. When you divide 699 by the required number, the remainder is 6. That is the meaning of respectively. So therefore, again let us subtract. 445 minus 4 will give you 441. 572 minus 5 will give you 567, and 699 minus 6 will give you 693. Now why do we subtract? I have already explained in the previous question. We subtract because the question says greatest number, and here greatest number means HCF, and when you find the HCF, the remainder has to be 0. Now how to make the remainder 0? Where the remainder is already 4, 5 and 6. So in order to make the remainder 0, you subtract the remainder from the number. Therefore, I am subtracting here 4, 5, 6. So what do you get? So therefore, the required number equals to HCF of 441, 567, 693. Using Euclid's division algorithm, we get, now, take any two big number, which is bigger? I'll take this and this. 693 and 567. Between these two, which is bigger? 693 is bigger. So we divide 693 by 567. Let us try. 693 divided by 567. 567 ones are 567. Now 3 minus 7, 13 minus 7 will give you 6. This is 8. 8 minus 6 will give you 2. This is 6. 6 minus 5 will give you 1. Now you can write down 567 into 1 plus 126. The remainder is not yet 0. Divide 567 now with 126. That is divide. 126 will divide 567. 126, let us do 4s are. 4 6 are 24, carry 2. 4 2 are 8 plus 2, 10. Carry 1. 4 on the 4 plus 4, 1, 5. You have 7 minus 4 is 3, 6. So this can be written as 126 into 4 plus 63. The remainder is not yet 0. Again, let us divide. 126 by 63. Let us divide. 63 will divide 126. 63 2s are 126. Therefore, the remainder is 0. You can write down 63 into 2 plus 0. Now here, our HCF is this one. This is our HCF here. Therefore, HCF of these two numbers, 693 and 567 will give you 63. Now, let us go for another part. Since there are three numbers, there will be two parts. Again, taking what is left. From these three numbers, you've already taken two numbers, this and this. Now this is left. 441 and 63. Using Euclid's division algorithm, we get, again, as for the rule, let us take the bigger number. Divide 441 by 63. Let us divide. 441. Let us try with 7s up. 7 3 is 21, carry 2. 7 6 is 42 plus 2, 44. Now I am getting the answer directly. 63 into 7 plus 0. I am getting 0 directly. Since I got the 0 directly, what is our answer? Our answer is 63. Similar question we have done in the previous question also. So you can write down, hence the required greatest number is 63. That is our answer. Let us move on to the next question. Let us try this question number 5, which says, using Euclid's division algorithm, state whether the numbers 47 and 149 are co-primes or not. Now what are co-primes? I'll just give you a small example. 2 and 3 are co-primes. 4 and 5 are co-primes. 7 and 9 are co-primes. So what are co-primes? Co-primes are those numbers whose HCF is 1. If the HCF of the given numbers is 1, then the numbers are said to be co-prime. And if the HCF is not 1, the numbers are not co-prime. So in this case, we have to state whether the numbers are co-prime or not. Let us find out the HCF by Euclid's division algorithm. And if the HCF is 1, 47 and 49 are co-prime. And if the HCF is not 1, they are not co-prime. Let us start. Given numbers are 47 and 149. Using Euclid's division algorithm, we get, now as per the rule, which is bigger, 149. Divide 149 by 47. Let us divide here. 47 will divide 149. 47, let us solve 3s are 7 3s are 21, carry 2. 4 3s are 12 plus 2, 14. You have 8. So you can write down 47 into 3 plus 8. The remainder is not 0. Let us come. 47 will be divided by 8. Let us divide 47 by 8. 8 7s are 46. 1. Oh, sorry. Let us divide 47 by 8. 8 5s are 40. You have 7. 8 into 5 plus 7. Still the remainder is not 0. Let us divide 8 by 7. Let us divide 8 by 7. 7 1s are 7. 1. You have 7 into 1 plus 1. Still the remainder is not 0. Now divide 7 by 1. 1 7s are 7. Now the remainder is 0. So you write down 1 into 7 plus 0. Now the remainder is 0. And if the remainder is 0, check the number which is ahead of 0. 1. Now what do we get here? We get here HCF is 1. Therefore, HCF of 47 and 149 equals to 1. Hence, they are co-primes. That is our answer. If the HCF is 1, the numbers are co-primes. If the HCF is not 1, the numbers are not co-primes. Let us go for one more similar type of question. Let us try question number 6, number 1, which says, using Euclid's division, find which of the following pair of numbers are co-primes. Again, similar type of question. Given numbers are 272 and 1032. Using Euclid's division algorithm, we get, again, which is bigger, 1032. Now divide 1032 by 272. Let us divide. Now 272 will divide 1032. Let us divide 272 3s are 3 2s are 6, 3 7s are 21, carry 2, 3 is 6 plus 2 8. Now let us subtract. 12, carry here, 12 minus 6 is 6, this is 2, 2 minus 1 is 1, 10 minus 8 is 2. So you have 272 into 3 plus 216. Again, remainder is not yet 0. Divide this 272 by 216. 216 will divide 272. 216 ones are 216. Let us subtract. 12 minus 6, 6. This is 6 minus 1 is 5, 56. You will have 216 into 1 plus 56. Again, let us divide 216 by 56. 56 will divide 216. 56 3s are 6 3s are 18, carry 1. 5 3 15 plus 1 16. Carry here 16 minus 8 is 8. This is 0. Now carry here 10 minus 6 is 4, 48. So you can write down 56 into 3 plus 48. Still not 0, go for next. Now 56 will be divided by 8, 48. Divide 56 by 48. 48 ones are 48. So the remainder is 8. You can write down 48 into 1 plus 8. Again 48. So divide 48 by 8. 48 divided by 8. 8 6 are 48. Now the remainder is 0. 8 into 6 are 48. Now you got remainder is 0. Therefore our HCF is 8. Therefore HCF of 272, 1032 equals to 8. Now HCF is 8, fine. But is it a coprime? No, it is not a coprime. Now why it is not a coprime? As we have discussed in our previous question, for a number to be a coprime, the HCF must be equal to 1. So you can write down, since HCF of 272 and 1032 is not equals to 1, hence the given pair of numbers are not coprime, Now this is our required answer. For a number to be a coprime, the HCF must be equals to 1. With this, we have come to the end of exercise 1A. Let us now start with exercise 1C. Now in this exercise, the question says, find the prime factorization of the following numbers. First one, 96. Now we all are aware of what is prime factorization. Now prime factorization means you have to convert any given number as a product of its primes. Now what are prime numbers? It is very easy for all of us, is not it? What are prime numbers? A prime number is that number which has only two factors. And what are they? The number itself and 1. Now, you have to convert this 96 as a prime factors. Now, let us start. Now, how to convert 96 as a prime factors? Very simple method. Let us do in this way. This method is known to all of us, is not it? Now, let us try this method. Now, let us 2 4s are 8, carry 1 16, 2 8s are 16. 2 2s are 4, 2 4s are 8. 2 12s are 2 6s are 2 3s are 3 1s are. Now, therefore, 96 equals to, now how many 2s are there? 1, 2, 3, 4, 5, 5 2s and 1 3s. Is not it? Right now. 2. This is our answer. Or you can further write 2 to the power 5 into 3 to the power 1. That is our answer. But this is called as a product of prime factors. See, 2 is also a prime number, 3 is also a prime number. So you are expressing 96 in the form of 2 and 3, which are primes. Now let us go for next question. Number 2, 408. Let us convert this 408 as a product of its prime factors. You have 408. Let us try. 2 2s are 4, 2 zeros are 0, 2 4s are 8. Again, 2 1s are 2, 2 zeros are 0, 2 2s are 4. 2 5s are 10, 2 1s are 2. 3 1s are 3, carry 2 21, 3 7s are 21. 17 1s are 17. So write down therefore 40A equals to 2 into 2 into 2 into 3 into 17, which is also equals to 2 to the power 3. Why 3? Because it's a product of 2 3 times into 3 to the power 1 into 17 to the power 1, which is our required answer. Now let us go to question number 2. Let us solve this number 2, which says express 16,380 as a prime factor. Same method. Let us start. Let us start with 2. 2 8s are 16. 2 1s are 2. Carry 1. 18. 2 9s are 18. 2 0s are 0. Again. 2 4s are 8. 1. You cannot do 1 with 2. So 2 0s are 0. 1 will go here 19. 2 9s are 18. 2 5s are 10. Again. Now you cannot divide with 2 because this is 5. Odd number. So let us start with 5 directly. 5 8s are 40. 5 1s are 5, 45. 5 9s are 45. Let us try with 3. 3 2s are 6. Carry 2. 21. 3 7s are 21. 9. 3 3s are 9. Again, let us start with 3. 3 9s are 27. 3 1s are 3. Let us do with 7. 7 1s are 7. Carry 2. 21. 7 3s are 21. You have 13 1s are 13. Therefore, 16380 will give you 2 into 2 into, I'll write down first 3. 3 into 3 into 5 into 7 into 13, which can also be written as 2 to the power 2, 3 to the power 2, 5 to the power 1, 7 to the power 1, 13 to the power 1, which is our required answer. So this is how we convert any number or express any number as a product of its prime factors. Now let us move on to the next question. Now let us look at question number 4, which says find the HCF and LCM of the following pair of integers by applying fundamental theorem of arithmetic. Now we'll understand what is fundamental theorem of arithmetic while doing this question, and what is HCF. HCF means highest common factor, means first you check the factor which are common, and out of the common factor take the highest one. LCM, lowest common multiple, first you check again the multiples, from that multiples, common multiples, check the lowest one. Okay, so we are aware of HCF and LCM, is not it? We have done this in our junior classes. Now let us try here. First let us convert 336 as a product of its factors. First let us write down like this. Let us check 2 1s are 2, 2 6s are 12, 2 8 are 16. 2 8 are 16, 2 4s are 8, 2 4s are 8, 2 2s are 4, 2 2s are 4, 2 1s are 2, 3 7s are 21, 7 1s are. Similarly, let us try, let us do for 54 also. 2 27s are 54, 3 9s are 27, 3 3s are 9, 3 1s are 3. So therefore, let us write down 336 as a product of its factors. 2 into 2, 2 into 2 into 3 into 7, and 54. 2 into 3 into 3 into 3. Now, from these two factors, now, see, HCF, Now, out of these two product of factors, first check out which is common. Common, write down only once. Anything common now? Yes, one more thing is common. 3 common, write down into 3. Anything common now? No, here is 2, but there is no 2. 3, not extra 3. So that is our HCF. 2 3s are 6. And LCM. Now, in LCM, first you check what is common. 2 common, write down once. 3 common, write down once. Now write down everything what is remaining. 2 7. 2 7. 3 3. Now we can multiply this. 2 3 is 6. 6 2 is 12. 12 2 is 24. 24 2 is 48. 48 into 7 3 3. Let us multiply. Let us multiply. How much do we get? 2 3 is 6. 6 2 is 12. 12 2 is 24. 24 2 is 48. Okay, let us write down here 48. 7 3 is 21. 21 3 is 63. Let us multiply. 3 8 is 24. Carry 2. 3 4 is 12. 13 14. 6 8 is 48. Carry 4. 6 4 24 plus 4 28. 4 2 0 3. So our answer is 3024. So therefore our HCF is 6 and LCM is 3024. This is our answer. So this method by which we have done, this method is called fundamental theorem of arithmetic. Alright, so with the help of this method, we are able to find out the HCF and LCM of any given numbers. This is our required answer. Let us move on to the next question now. Now let us look at question number 5, which says, find the HCF and LCM of the following pairs of integers by using prime factorization method and verify that LCM into HCF equals product of two numbers. Now what is the second prime factorization method? Same method that we have done in the previous question, exactly same. Now, new thing has come out here. LCM into HCF equals to product of two factors. I have written down in this formula in a box. I have written down this formula in a box. Why? Because this is an important formula. So we have to verify this formula also in this question. Now let us start. Now again, let us write down 26 as a product of its factors. 2 13s are 13 1s are. Again 91. 7 1s are 7. 7 3s are 21. Therefore, 26 write down 2 into 13. 91 write down 7 into 13. Now check which is common in this 2. 13 is common. Now HCF is 13 only. Why? Because only 13 and nothing else is common. And LCM. The first write down what is common only once, 13. Now what is left? 2, 7. Now you have to multiply them. 13, 7 2s are 14. Now multiply them. 13 into 14. 4 3s are 12. Carry 1. 4 1 4 plus 1 5. 1 3s are 3. 1 1s are 1. You have 281. 182. 182. Now comes the second part. Verify that LCM into HCF is equal to product of two numbers. Now, let us try. Verification. Let us do verification. Now, you have HCF also and you have LCM also. So therefore, let us find out LCM into HCF is how much? 182 into 13. Let us multiply them. How much do we get? 182 multiplied by 13. 3 2s are 6. 3 8s are 24. Carry 2. 3 1s are 3 plus 2, 5. 1 2s are 2. 1 8s are 8. 1 1s are 1. Let us add them. 6. 4 plus 2, 6. 5 plus 8, 13. Carry 1, 2. 1 plus 1, 2. You have 2 3 6 6. So this is the product of HCF and LCM. Now, and product of two numbers is, what are the two numbers given to us? 26 and 91. 26 into 91. Let us multiply again. 91 multiplied by 26. 6 ones are 6, 6 nines are 54. 2 ones are 2, 2 nines are 18. 6, 6. 8 plus 5, 13, carry 1, 1 plus 1, 2. So you have 2, 3, 6, 6. Let me clear this. Now we have seen that HCF, LCM into HCF is 2366 and product of the two numbers is again 2366. Are they not equal? So you can write down, hence LCM into HCF equals to product of two numbers. Verified. So this is our answer. So what we have learned now, whenever two numbers are given to you, the product of that two numbers and the product of its LCM and HCF are equal. That means LCM into HCF equals to product of two numbers. This is also a formula which we'll be using in our next question. Now let us look at this question number 6, which says, given that HCF of 306 and 657 is 9, find the LCM of 306 and 657. So in this case, given two numbers are 306 and 657 and HCF is 9. You have to find LCM, is not it? We know that formula, LCM into HCF equals to product of two numbers. Now LCM, we don't know, we have to find LCM. HCF is 9. Product of two numbers. Product means multiply. Two numbers are 306 and 657. LCM equals to 306 into 657 by 9. Now let us cancel them. 9 ones are 9. 9 threes are 27. Carry 3. 36, 9 fours are 36. So what do you have here? LCM equals to 34 into 657. Now let us multiply 34 into 657. 657 multiplied by 34. 4 sevens are 28, carry 2. 4 5 are 20 plus 2, 22, carry 2. 4 6 24 plus 2, 26. 3 sevens are 21, carry 2. 3 5 is 15 plus 2, 16, 17, carry 1. 6 is 18 plus 1, 19. 8, 3, 13, 12, 2. Therefore, LCM of the two numbers is 2, 2, 3, 3, 8. And that is our required answer. Let us move on to the next question. Now let us look at question number 7. Which says, find the HCF and LCM of the following positive integers by applying the prime factorization method. Same method, but here we have three numbers. What are they? 24, 36 and 176. Now let us first convert these numbers as a product of its prime factors in this way. 2 12s are 24, 2 6s are 12, 2 3s are 3 1s are again 36. 2 18s are 36, 2 9s are 18, 3 3s are 9, 3 1s are 176. 2 8s are 16, 2 8s are 16, 2 44s are 88, 2 22s are, 2 11s are 11 1s are. So therefore, 24 can be written as 2 into 2 into 2 into 3. 36 can be written as 2 into 2 into 3 into 3. and 176 can be written as 2 into 2 into 2 into 2 into 11. Now therefore, what will be the HCF? Now let us look here. Now as I said, first check the common factors. 2 is common, 2 is common, 2 is common. Write down 2 here once. Into, again, 2 is common, 2 is common, 2 is common. Write down 2 here only once. So anything you have common in all the 3. 2, no, only 1, 2. But here there is no 2. 3, 3, there is no 3. So no more common is left now. So this is our HCF, 4 and LCM. Now first write down whatever is common in all the 3. 1, 2, 3, write down once, 2. Again, 1, 2, 3, write down 2. Now write down what is common in 2 now. You have 3, 3. Now 3. You have 2, 2. Write down 2. Anything common in two numbers? No. 3, 3, done. 2, 2, done. This, done. Okay. Now what is left? 3, 2, 11. Write down 3, 2, 11. Now you have to multiply them. 2 2s are 4, 4 3s are 12, 12 2s are 24, 24 2s are 48. I'll write down here 48, 48 into 33. 8 3s are 24, carry 2. 3 4 12 plus 2, 14. 3 8s are 24, carry 2. 3 4 12 plus 2, 14. You have 4, 8, 5, 1. So therefore your answer will be 1584. Now again, for HCF you have to check the common in all the 3 terms, But in LCM you check in all the 3 terms, fine. If you don't have common in all the 3 terms, check 2 terms. Here, or here. Fine. And after that, write down whatever is remaining. That will give you your answer. So this is our required answer. Now let us move on to the next question. Now let us look at this question number 9, which says, find the smallest number which when divided by 35, 56 and 91 leaves remainder 7 in each case. Now here the question asks for smallest number. In previous questions they were asking greatest number or the biggest number. Now we are asked smallest number. So when they say biggest number or the greatest number, it is HCF, and when they ask smallest number, it is LCM. Now let us start. Find the smallest number. So when the required smallest number is divided, when you divide that required number by 35, the remainder is 7. When you divide that required number by 56, the remainder is 7. When you divide that required number by 91, the remainder is again 7. So when the required number, smallest number, when the required smallest number is divided by 35, 56 and 91, the remainder is 7 in each case. So therefore, the required smallest number is what? Therefore, the required smallest number equals to, you have to write down LCM of 35, 56 and 91 plus 7. Why 7? Because if you get the remainder 7 now, you have to add 7 so that at the end you will get 7 as the remainder. That is why we are adding 7 here. Now let us find out the LCM, but not with this time factorization method. Let us use the old traditional method, okay? So how do we do? Write down 35, 56, 91. If you remember, we should do it in this way. In our junior classes, we should find the LCM using this method. Now let us do it 7. 7 5 to 35, 7 8 to 56, 7 1 to 7, 7 3 to 21. Now let us do with 5. 5 1 to 5. This one cannot be done with 5, so let it be as it is. 13, And let us do with 13. 1, 8, 13, 1 is 13. Let us do with 2. 2 4s are 8. 2 2s are 4. 2 1 1. So we do unless we get 1 1 1 here. So therefore, what is the LCM? First we find out the LCM. LCM of 35, 56 and 91 is how much? 7 into 5 into 13 into 2 into 2 into 2. Now let us multiply them. 7 5s are 35. Write down here 35. 13 2s are 26. 26 2s are 54. 54 2s are 108. 108. Now let us multiply 35 into 108 into 35 into 108. Let us try here. 108 into 35. 5 8s are 40, carry 4. 5 to 0 plus 4, 4. 5 1s are 5. 3 8s are 24, carry 2. 3 0 0, 0 plus 2. 2, 3 1s are 3. So the answer is, the LCM is 3, 7, 8, 0. So here we have got just the LCM and our answer is not yet done. So let us find out the last answer. I'll just write down here. Therefore, the required smallest number equals to what is the required smallest number? LCM of 35, 56, 91 plus 7. What is the LCM? 3, 7, 8, 0 plus 7. When you add them, you will get 3, 7, 8, 7. That is our required answer. So when they say the smallest number, it is LCM, and when they say the biggest number, it is HCF. So with this, we have completed our exercise 1C. Now let us move to the next exercise. Now before we start with the next exercise, that is exercise 1E, let me give you a theorem. Theorem here is very simple, very easy to understand. Now let x equals to a by b be a rational number such that the prime factorization of b is of the form 2 to the power m into 5 to the power n, where m and n are non-negative integers. Then x has a decimal expansion which terminates. Now we are talking about terminating decimals. Now what is terminating decimals means? When the division of a certain number stops, it completes, then we say the division, the decimal, the number is a terminating decimal number. Now what does it mean? 2 to the power m into 5 to the power n. Now you have to check the denominator. These are some examples. Now check. 8 by 5. Now 8 by 5 I can write down in the form of 2 to the power 0 into 5 to the power 1. Why? 2 to the power 0 is 1. 1 into 5 is 5. Same. This is why I am doing this. I want to convert this one into this standard form. 2 to the power m, 5 to the power n, which is of the form 2 to the power m, 5 to the power n. Therefore, this is terminating. 20. 19 by 20. Check the denominator only. Okay, not the numerator. Check the denominator only. 2 to the power 2 into 5 to the power 1. 2 to the power m, 5 to the power n. 17 by 400. 2 to the power 4 into 5 to the power 2. To the power m into 5 to the power n. So if the denominator of a certain number is of the form 2 to the power m, 2 to the power m into 5 to the power n, then only the number is said to be terminating. And if the number is other than 2 and 5, suppose you have 2 and 3, you have 3 and 7, it is not terminating. It is not terminating. Either you must have only 2, only 5, or both 2 and 5 in the denominator. Okay, you have only 2, no problem, that is also terminating. You have only 5, that is also terminating. And you have both 2 and 5, that is also terminating. But any number other than 2, 5 or 2 and 5, that is non-terminating decimal. So this is a very simple theorem, very simple formula to understand. Just remember 2 to the power 5 m into 5 to the power, Yes, to the power m into 5 to the power n. If the denominator of a certain number has a prime factors into this form 2 and 5, then it is a terminating decimal. So let us move on to the questions of this exercise. Let us look at this question number 1, which says if a by b is a rational number where b is not equal to 0 in its lowest form, remember lowest form, what is the condition on b so that the decimal representation of a by b is terminating now? If you recall, just now I have given you one theorem which says that for a number to be a terminating decimal, the prime factorization of its denominator must be of the form 2 to the power m into 5 to the power n. Now, what is the condition? First, the rational number is in its lowest form. This is very, very important. It has to be in the lowest form, means you cannot divide or cancel further. Now, what is the condition on b? Therefore, the condition on b is that the prime factorization of b must be of the form 2 to the power m into 5 to the power n, so that the decimal representation of a by b is terminating. That is our answer. So what is the condition on b? So the condition on b is that the prime factorization of b must be of the form 2 to the power m into 5 to the power n, so that the decimal representation of a by b is terminating. Now let us look at question number 2. Question number 2 says, is it correct to say that the number 343 by 2 into 7 into 5 square has a non-terminating and repeating decimal expansion? Is it correct to say? Now first of all, let us check whether the given number is in the lowest form or not. Now if you see here, it is cancelable. 7 1 is 7, 7 4 is 28, 7 9 is 63. So what do we have? We have 49 by 2 into 5 square. Now we are not asked to convert. We are just checking by ourselves to find out whether the number is in its lowest form or not. Now since the number was cancelable, therefore the number is not in its lowest form. So is it possible, is it correct to say whether the number has a terminating and a repeating decimal? Is it correct? Because the number is not in the lowest form, and for us to say whether a number is non-terminating or terminating, it has to be in the lowest form. Very important. So in this case, the number is not in the lowest form. So the answer will be, is it correct? No, it is not correct. Why? Because 343 by 2 into 7 into 5 square is not in its lowest form. So that is our required answer. Since the number is not in its lowest form, therefore it is not correct. No, because 343 by 2 into 7 into 5 square is not in its lowest form. That is the answer to this question number 2. Let us move on to the next question. Let us now try these last questions of this chapter. Now question number 3, which says, without actually performing the long division, state whether the following rational numbers will have terminating decimal expansion or non-terminating repeating decimal expansion. Now let us try number 1. You have 125 by 44. Now the question says without performing long division. Now which method? If you look at that theorem which says the prime factorization of the denominator must be in the form 2 to the power 5 into 5 to the power n. First let us find out what is the prime factorization of 44. 2 2s are 2 2s are, 2 11s are 11 1s are. So you can write down, therefore 125 by 44 equals to 125 by what can you write? 2 square into 11. Now this is of the form 2 to the power m, but this is not of the form 5 to the power n. This is of another form. So since the prime factorization of the denominator is not of the form 2 to the power m into 5 to the power n, therefore 125 by 44 is non-terminating repeating decimal expansion. That is our answer. Now, if the prime factorization of the denominator is not of the form 2 to the power m into 5 to the power n, therefore the given number is a non-terminating repeating decimal expansion. Now let us check number 2. Let us check number 2. Let us check number 2. You have 23 by 8. Again, let us find out the prime factorization of 8. 2 4s are 8, 2 2s are 4, 2 1s are. So you can write down, therefore 23 by 8 equals to 23 by 2 to the power cube. Also you can write down 2 to the power 3 into 5 to the power 0. Why? Because 5 to the power 0 is 1. 1 into 2 to the power 3 is 2 to the power 3. Now if you look at this, 2 cube into 5 0 means 2 to the power m into 5 to the power n. Since the prime factorization of the denominator is of the form 2 to the power m into 5 to the power n, therefore 23 by 8 is a terminating decimal expansion. That is our required answer. Now in this case, since the prime factorization of denominator, this denominator is of the form 2 to the power m into 5 to the power n, therefore 23 by 8 is a terminating decimal expansion. Now let us look at question number 4. Now question number 4 says, write down the decimal expansion of the following rational numbers by writing the denominator in the form 2 to the power m into 5 to the power n, where m and n are non-negative integers. First you convert this one into this form and again convert into the decimal expansion. What is given to you? First answer number 1, 3 by 8. Therefore 3 by 8, first let us find the prime factors of 8. 2 4s are 8, 2 2s are 4, 2 1s are. So you can write down 3 by 2 cube, which can also be written as 3 by 2 cube into 5 to the power 0. Fine. Also, and 3 by 8 equals, so let us divide. The question says, write down the decimal expansion, decimal in terms of decimal, and let us write down. Let us divide 3 by 8. 8 zeros are 0, 3, give point 0. 8 threes are 24, 6. After decimal, you have given the number, give here 0. 8 sevens are 56, 4, 0. 8 fives are 40. So therefore 3 by 8 equals to 0.375, which is our required answer. Now let us try number 2. Let us again convert this 80 in terms of 2 to the power 5 into 5 to the power n. 2 to the power m into 5 to the power n. 2 40s are 80, 2 20s are, 2 10s are, 2 5s are, 5 1s are. So you can write down, therefore 7 by 80 equals to 2 to the power 4 into 5 to the power 1, which is of the form 2 to the power m into 2 to the power, 5 to the power 1, n. 2 to the power m into 5 to the power n. And let us divide 7 by 80. 80 zeros are 0. 7 give you a point. 0. Again you cannot do 80 zeros are 0. Again 70. Now give here 8. 88 are 640. You have 60. Again give 0. 87 are 560, again 40, give 0. 85 are 400. So the answer is 7 by 80 equals to 0.0875. That is your decimal expansion. So with this, we have come to the end of chapter 1. If there are any questions, any queries, you can write down in the comment section. I'll try to solve them in my next video I upload. Thank you very much.